Good evening, everyone. How are you today? Sorry it got so late, but I'm gonna go ahead and post a video of these solutions to the practice problems for the exam. That we can have the solutions and use them to try to study. First, let's find the inverse. So we went over this in class today. I said when you find the inverse, the first step is you need to switch the x and y. Then the second step is you solve for y. So what does that look like in an example problem? Let's take a look at 1a. So first we're going to switch x and y. Literally just swap them out, okay? Everywhere there's an x, you put a y, and everywhere there's a y, you put an x. Now we need to solve for y, which means get the y by itself on one side of the equal sign. The way we do that is we move everything else over. So let's get rid of this negative 6. Those will cancel. We'll have x minus 6 equals 2y. Now I need to get rid of this y, so I will go ahead and divide both sides by 2. Those will cancel. Then I have y equals x over 2 minus 6 over 2. All I did was kind of split this up into 2, and instead of 6 over 3, I know that 6 divided by 2, instead of 6 over 2, I know 6 divided by 2 is 3, so I'm going to write 3. And that's it. Remember, instead of y, this is the new y, which is the same as, to identify the inverse, we're going to use f to the negative 1 of x. So this is the same as f of x is 2x plus 6. And this one, we're going to write f to the negative 1 of x. And that's how we designate the inverse. Okay. Take a look at number 2. We're going to do the same steps. The first part is switch the x and the y. We have the third. Okay, so let's get everything over to the other side of the equal sign. That's going to go to 0. X plus 8 equals 4y to the third. Now I need to get rid of this 4 hanging out in the front. So I'm going to divide by 4. That will cancel. And then divide everything over here by 4. At the end, I'm going to have y to the third equals x over 4 plus 8 over 4. And I know that 8 divided by 4 is the same as 2. So now this is the last step, and this is just a rule that we need to remember from Algebra 1. Okay? When we're trying to isolate, we do the opposite operation. So if it's like multiply, we divide. If it's addition, we subtract, and so forth and so forth. The opposite of an exponent is the square root or the cube root of it. If you have a squared, then the opposite is a square root, okay, of whatever's inside. So let me show you what that looks like as an example. Okay. If I have y to the third power, the way I can cancel that exponent of 3, the only way I can do that is by taking the cube root of that. And what happens is this cube root cancels with that exponent, and that just equals y. So let's go back to this. This is just a rule. Let's put this off to the side, okay? This is a rule from algebra. Now let's go back and look at this and say, how do I get rid of the exponent? Well, I just told you I've got to take the cube root, and whatever I do to one side, I have to do to the other side. Those will cancel. We'll have y equals the cube root of x over 4 plus 2. And that's it. And remember, instead of y, I'm going to identify the inverse by writing f to the negative 1 of x. So let's do this one. I'm going to ignore this for now. All I'm going to do is worry about this. So remember, I switch x and y. Add 3 to both sides. Cancel. So remember this rule. If I have an exponent of 2, I have to take the square root of both sides to cancel. These square roots cancel. And have y equals the square root of x plus 3. And I just have to leave this where I say x has to be greater than or equal to 0. That's just a restriction that we need to add. It's just saying that x cannot be any number bigger than 0. Okay, for number 2, these are the super easy ones. There's nothing you're going to see that's easier than this. The first step of an inverse is, remember, switch x and y. So that means the x's become y's and the y's become x's. So here I'm going to write -1, -5. Here I'm going to write 1, -1. For this one, it's going to be the same, 3 and 3. And this one's going to be 4, 5. I'm literally just swapping out the x's and the y's. So now remember, to graph, all you need to do is plot the coordinate point. So let's plot this one in purple. I'm going to go to -5, -1. Then I go to -1, 1. Then I go to 3, 3. Then I go to 5, 4. Connect the dots, makes my straight line, and that's the graph of the equation. Now let's do this one in blue. The inverse. -1, -5. 1, -1. 3, 3. 4, 5. So I just took these points and I put these points and I plotted them over here. Now I connect this line. And that's the graph of the function in purple. And then the graph of the inverse is right here in blue. Okay. We're going to need to know that, and we're going to need to see these graphs in order to answer part C. So remember, all I do is I switch the x and the y. So that becomes 0, -1, 1, 0, 4, 1. I'm going to graph this in purple. So it's -1, 0, 0, 1, and 1, 4. I'm going to graph this one in blue. 0, -1, 1, 0, 4, 1. Okay. And then on C, we're going to see the graph of a function, one function which is like this one, and the inverse, which is like this one, which we write as this, will reflect across the line. So which line does it reflect on? So I want you to take a look along this line. If I drew a line, an imaginary line this way, in red here, see how it looks like the purple line is a reflection across this line to the blue line. So what we're saying is that for every point on this line, there's a counterpoint on this line across the red. And we're saying the same here. For every point on this line, there's an equal point on this other line. So that, we know that when it's an inverse, we're going to have a reflection across y equals x, which is what this red line is. It's called y equals x. Absolute values. We spend a lot of time going over these in class. Let me write down the rules. Remember, the first step is isolate the absolute value. The absolute value is everything that's inside the bar, whatever number that can be. Then the second step is what we have said in class is split the bars. Okay. Say split the bars. Mathematically, that means make two equations. One is equal to a positive number, and the second one is equal to a negative number. Okay, so let's start with this one. 4a. The absolute value bar is not isolated. It has the 6 in the front. We're multiplying 6 by times everything that's here. In order to get rid of it, we need to do the opposite. So that means divide by 6. Those go away. And then we have 18 divided by 6, which is 3. Now that this is just by itself, we can go ahead and do step 2, which is split the bars or create our two equations. The first equation is x minus 9. Everything that's inside the bars equal to the number on this side of the equal. The second equation is the same, except we change the sign of this number to a negative. Now we solve each of these. Add 9 to both sides, so cancel, and x will equal 9 plus 3, which is 12. Add 9 to both sides, x is equal to 9 minus 3, which is the same as 6. Those are my two answers. Take a look at this one. So I've got three parts. I'm adding 10. I've got the absolute value, and then I'm multiplying by 8. So what I need to do is do the easiest thing first, which is add or subtract. I'm going to write it right here as a side note. Add, subtract first. Multiply, divide second. So let me show you what that looks like. We're going to do this first. Add or subtract first. So we're going to subtract 10 from both sides. That will cancel. 10 minus 10 is 0. Then we do the multiply divide. Excuse me. In this case, since we're multiplying out here by 8, we're going to divide everything by 8 in order to cancel these out and just have x plus 9 equals to 0 divided by 8, which is 0. Now, normally we make two examples. One is set to the positive number, and then the other one is set to the negative of that number. But remember, we can't really have a negative 0. So this is one of the few cases that we'll just have one equation. We can subtract 9 to both sides. Those will cancel, and I'll have x equals negative 9 as the answer. Let's look at the last one very quickly. So don't have any addition or subtraction here on this problem, but I am dividing by 5. So in order to cancel that 5, I'm going to multiply everything up here by 5. So I can cancel those two. Then I have to multiply the other side by 5. I'm left with 3x minus 1 equals 25. Then I can split the bars and do 3x minus 1 equals 25. And the second equation is 3x minus 1 equals the negative of this number. So it's negative 25. And then I solve as normal. Remember, doing the addition and subtraction first to isolate, and then the multiplication. So I'm going to do this first. Those cancel. And then I'm going to divide. We can leave this as that answer. 26 over 3. Then divide by 3. And x is going to equal negative 8. Now, to find the extraneous solutions, we do exactly what we did in the other problems. We have to isolate this, so we're going to do the subtraction first. Those cancel. 7 minus 2 is 5. Then we still have to get rid of this guy, okay? This negative out here, we're going to get rid of it. We're basically multiplying everything by negative. So we're going to divide by a negative. That will cancel the signs out. And then I'll be left with x minus 4 equals negative 2 divided by negative 1 is a positive 2x, and then negative 5. That's what that becomes. Okay. Now that this is isolated, we split it into two equations. And then the second equation, we have to do what's inside to the negative of the other side. So we switch all the signs. So these are our two equations. Then we have to solve like we normally do. That becomes negative x minus 4 equals negative 5. Then I'm going to add 4. And then I just want to make sure I don't have negatives in front of the x, so I switch the sign so x becomes 1. I do the same for this side. Or for, I'm sorry, the second equation. Those cancel. I've got x equals negative 2x plus 9. Bring this 2x to the other side. Those will cancel, and then I'm going to have 3x equals 9. Divide by 3. And I've got x equals 3. Now the extraneous solution part is where I take this one, I substitute it back into here, and see if the equation is true or not. Then I do the same for this one. I plug it back into this equation and see if it makes it true. If it's true, it's a good solution. If it's not true, it's extra. Okay. This, what I would do for number 6 is I would graph this in Desmos or in the TI Inspire. Once you do that, you're going to see that it's going to look like this. I would graph this f of x equals the absolute value of x. And then I would start graphing these one by one, and you're going to see that what this one's going to do is going to shift over 1, 2, 3, 4 spaces to the right, and it's going to get a little bit skinnier. And what it's asking you is compare the graph of this to the graph of this, and then see how it moved. Okay, so you can see it shifted over 4 spaces, and it got a little bit skinnier. Now I would do the same for these, is just graph them into Desmos or the TI Inspire. Okay. For each of these, you would graph them. I would also just graph these in the calculator. Hold on. Okay, so I would graph these in the calculator. In order to get the graphs. Okay, so to get this part, I would just graph from the calculator. And then in order to solve them, there's 2 ways to do it. You graph them in the calculator, and wherever they intersect, that's the solution. The other way you can do it is to use the linear solve, which in the TI Inspire is menu, then 3, then 2. You're going to select 2 equations, and then you're going to get the 2 solutions. So let me write down the equations and then show you. Y equals 2x plus 1, y equals 4x minus 1. Let me go ahead and show you how we would do this in the TI Inspire so you can remember how to get the solutions for this. Okay, it's loading. We'll get there. So first you're going to do add calculator. Then you go to menu, 3 algebra, 2 linear solve, select 2 equations, hit OK, and then here you're going to type in the equation. Y equals 2x plus 1. And right here you're going to type in y equals 4x minus 1. Hit enter, and those are your two solutions. 1 comma 3 is the solution for these two. So that's going to look like this. The solutions for this are x is 1 and y is 3. Okay? And you would do the same exact thing for that one. These you'll do the same. Use the TI Inspire, just like I showed you previously. This one, use the TI Inspire, but instead of 2 equations, you're going to select 3 equations. Okay. For this one, you would do the same thing. Use the TI Inspire, or actually, you know what? Instead of the TI Inspire, for this one, you need to do Desmos.com. Type exactly what you see here into Desmos for each function, and you're going to see it's going to create a shaded area on the graph for one function, and then the other function is going to be a different shaded area. And what you're going to see is basically this area that they're both shaded in. Those represent the solutions to both equations. Use Desmos.com for this one. And you will have access to that on the test tomorrow. Let's take a look at how to set these up, and then that'll be it. So remember, Anthony, Josh, and Dominic worked a combined 7 hours. So you've got 3 guys that you can represent with X, Y, and Z. And combined, they work 7 hours. So what you're saying is that Anthony plus Josh plus Dominic worked all together, and they worked 7 hours in total. Okay, but to make it a little bit easier, instead of writing everything out by name, we're going to just call them by their variables. So we're going to say x plus y plus z equals 7. Okay. Now let's take a look at, we need the second equation. Dominic worked twice as many hours as Anthony with 1 extra hour. So remember, Dominic we're representing with the letter Z. So I'm going to write Z equals. It says he worked twice as many hours as Anthony. So he worked twice as many hours as Anthony. So we're going to multiply Anthony's hours by 2, and then we're going to add 1 extra hour. So remember, Anthony, we're just using x, so we can write 2x. And then the last sentence says it's again Dominic, so we're going to type, instead of Dominic, we're going to write Z equals 5 more hours than Josh. So he worked 5 more hours than Josh. But instead of Josh, we're going to represent him with the letter Y. Okay, now you've got 3 equations, which you can use the TI Inspire to solve using linear solve, which is menu, 3, 2, and then 2 equations. 3 equations. And you'll get the X, Y, and the Z answers. Okay. So let's help you guys set up this one. Again, Jay, Earl, and Carlos. So we're going to call them X, Y, and Z. Together they worked. Together they have a total of 23 pencils. So X plus Y plus Z equals 23. J has 2 times as many as Earl. So we can say like J equals 2 times as many pencils as Earl plus 2. But remember, instead of Earl and J, we're going to call them X and Y. 0 is y plus 2. That's our second equation. Then our third equation is also in terms of j. It says he has 2 times as many as Carlos. And what else? That's it. Nobody else. So instead of j, we're going to write x, and instead of Carlos, we're going to write z. So we've got x equals 2z. Okay, and these are the 3 equations that we're going to put in the TI Inspire calculator and solve them like we just did the other ones. I will be available tomorrow from 8 to 8:30. So if you guys have any additional questions, please let me know, and we can go over them in class before school starts. Okay. All right. Good luck.